Hey, ladies and gents, I am going to start off this notes video with a bit of good news. This is the last notes that I'm going to give you. Yay! And it should be a pretty easy one. Once I explain what intermediate value theorem is, what IVT for short is, I think you all will be like, oh yeah, that completely makes sense. So hopefully, as long as I don't talk too long and too much, this should be a relatively short notes video. You are going to have a short Canvas quiz to take as well. And then like I said, last notes. Now, next week, we are still going to meet on Google Meet next week. This is the last notes, but we will still meet next week. So look for information on that. So notes are linked up here. I'm going to flip around my camera. And before we actually start with the notes that are linked up, quick introduction to intermediate value theorem. What is IVT? So let's pretend that you are driving down the road and your speedometer looks like this, pointing to 40 miles per hour. You're driving however long it is. 10 minutes later, I guess this says, you glance down, your speedometer looks like this. Now, side note, I realize these are not from the same car. I got these off the internet. So what do you notice about your speed other than your speedometer changed? Our speed went from 40 miles per hour to 100 miles per hour in a matter of 10 minutes. So if I asked you to give me a speed you are 100% sure that you must have gone in that time between being at 40 and then seeing you're at 100, I bet you all could list out a speed you must have gone. Some of you may say, oh, I must have gone 60. Some of you who would say, I must have gone 99. I must have gone 50. Now, I could have gone those speeds for just a split second, but I think you'd all agree, in order for me to get from 40 miles per hour up to 100, I have to pass every speed in between. Could I have slowed down, gone down to 20 and then sped up to 100? Yes, but I can't guarantee that I got slower. Could I have gone from 40 all the way down to 120 and then slowed down to 100 in those 10 minutes? Yes, I could have, but the only thing I can guarantee is that to get from 40 to 100, I must have, even for a split second, passed every speed in between. Now, and I realize this is kind of an old picture. Let's pretend you got the iPhone, the newest iPhone, and you paid $599 for it. A month later, let's say you're working at Verizon, and that phone is $399. At the end of the year, that same phone is $99. So it started at $599. Went down to $399, and by the end of the year, it was down to just $99. Is there another price you can guarantee me that phone must have cost between starting at $599 and ending at $99 besides the $399? Now, some of you may say, well, probably was like $199 at some point, or it probably was $299. But can you guarantee it? The answer is no. You can't guarantee it because with price, you can jump from one price to another price without passing everything in between. But when it comes to speed, to get from one speed to another, you must have at some point in time passed everything in between. The biggest difference between these two situations is speed is continuous and price is not. Speed is continuous, price is not. So there's something to be said about continuous functions. There's guarantees that we can make about continuous functions that we cannot make for discontinuous functions. And that really is what the intermediate value theorem says, is that if you are continuous, there's certain guarantees that I can make. So, just a little more of a math warm up to this intermediate value theorem. We have this cubic function, f of x cubed plus x squared. We're going to complete the table, and I'm going to do this without using my calculator. So I'm going to plug in 0. 0 cubed plus 0 squared is still 0. 1 cubed plus 1 squared is 2. 2 cubed is 8 plus 2 squared, which is 4, is going to be 12. So again, without using a calculator, when would f of x equal 1? Well, taking a look, I know 1, which is a y value right here, 1, which is a y value, would fit somewhere right here. 1 is halfway between 0 and 2. So f of x must equal 1 somewhere between 0 and 1. Between 0 and 1. Between x equals 0 and x equals 1. Now, why is it that I can say this? I can say this because f of x is cubic, is a cubic function, and f of x, any cubic function, is continuous. I can guarantee that this function must have equaled 1 between 0 and 1, because being continuous, in order for me to get from 0 to 2, I must have passed through 1, which means there has to be an x value somewhere between 0 and 1 that gave us a y value of 1. We can make a similar conclusion about this other function, which happens to be quadratic. You can take a look at that on my answer key that is linked up here. So like I said, here's technically what the intermediate value theorem, or IVT for short, says. IVT, you can totally call it IVT. It says that if you have a continuous function or a continuous interval, then you can guarantee that your function must hit every single value between our two endpoints every single time. So if a function is continuous, for example, from right here, if this function is continuous on this interval between 0 and 2, then I have to hit every value between a y value of 0, because that went with an x value of 0, and a y value of 12, because that went with the y value of 2. So really, what does that look like graphically? Graphically, it means if I have a continuous function, I'm just drawing some random continuous function here. Continuous because I can trace it from end to end without picking up my pen. I could have put finite points at the end. Remember, continuous non-mathematical definition is it is continuous from all the way on the left to all the way on the right if you can trace the graph without ever picking up your pen. So if I call this interval, let's call this the interval from A to B, and I'm just randomly choosing where it is, continuous on that interval, A to B, then this point right here has to be f of A, or the y value that goes with it. And then, I probably chose really poor points. We're going to choose a different B just so the y values are a little bit more separated from each other. We're going to call this guy B. We're going to call this guy B. Only so my y values are separated from each other, easier to see on this graph. So here's the B value, or the y value that goes with B, f of B. So what this says, and again, using just the terminology or the symbols that are up here, it says if I'm continuous between A and B, and here's the y values that go with those x values of A and B, then there is guaranteed to be a number, and they happen to call it C in the definition of IVT. There has to be another x value, C, between A and B. So if I call this C, there has to be a number between A and B whose y value is also between the two y values that correspond with A and B. It's really what it says. So in other words, if a function is continuous from one end to another, you can guarantee that at some point it has to pass every other number in between those two endpoints. This can be really helpful, as you can see right here, talking about behavior functions, finding intercepts, root zero solutions, whatever you want to call it, if you don't have a calculator. It also can be one of those, maybe one of those things that you have to verify that you can use intermediate value theorem in order to proceed on with more calculus concepts. So we're going to do two quick problems here, and then I'm going to let you be done with any new notes. So here we go. Verify that intermediate value theorem applies to the indicated interval. So first and foremost, in order for IVT to apply, you have to guarantee that you are continuous on the interval. And I can say that f of x is continuous. Sorry, it takes me a while to write here. Is continuous on the interval from 0 to 5 because f of x is a quadratic polynomial, and quadratics are continuous everywhere. all quadratics, all polynomials actually are continuous within their entire domain. Is quadratic and continuous everywhere. Now, if it was something that was not a function that was not continuous everywhere, and we'll get to an example like that, we would have to consider where those discontinuities are. So in this case, IVT applies because, again, it is a quadratic function, continuous everywhere. So then it says guarantee that, or find a C value guaranteed by the theorem. So keep in mind, just making some notes here, that the interval, all intervals, we knew this back, in algebra 2 really, but we reviewed this at the beginning of the year. All intervals are X values, unless you were talking about range, which we're not. And just based on this function notation, we know this is a Y value. So let's see. I just lost a pen somewhere, or a piece of paper somewhere. Sorry. Okay, so first and foremost, let's figure out, does 11 really even exist on that interval? So since this is a Y value, I need to find the Y values that go with the X values of 0 and 5. So first thing I'm going to do is find, now that I've determined I'm continuous, I'm going to find F of 0. Now this one's easy to do without a calculator. 0 squared is 0, plus 0 minus 1 is negative 1. And then I'm going to find F of 5. So let's see, we got 25 plus 5 is 30, minus 1 is 29. Is 29. I don't know why I put that minus there, only because I said minus 1. So positive 29. So I know intermediate value theorem definitely applies, not only because I'm continuous, but since 11 is between 29 and negative 1, then there has to be an X value, which right now we are calling C. Then there has to be an X value they're calling C that's between 0 and 5. So in order for me to get to this Y value of 11, I had to pass through some X value that's between 0 and 5. And I know that because 11 is between the Y values that correspond to these X values. So how would I find that Y value? Well, honestly, or find that X value, excuse me. Honestly, this is something that you've done back since algebra 1. This is a Y value, so I'm going to plug it in for F of X, which represents our Y. And we are going to solve for the X value. Now I notice I'm quadratic, so I'm going to subtract 11 to the other side. X squared plus X minus 12. I'm going to factor to solve, and I'm going to have X plus 4, X minus 3, which gives us X equals negative 4 and 3. So what does this mean for us? It means that this particular quadratic function has a Y value of 11 twice. That makes sense. A quadratic function is a U, so I'm going to hit 11 at 2 different locations. But I want to know what C value is on this interval. Well, negative 4 is not between 0 and 5, so this is not the X value we are looking for. 3 is between 0 and 5. So since 3 is between 0 and 5, then the C value we are looking for must have been 3. Now, again, for some of you thinking, well, this makes sense. Duh, like it's continuous, so I have to pass all those values, then great. Again, intermediate value theorem is one of those things that you sometimes just have to pass through in order to continue on with certain calculus concepts. Now, we're going to do one more. We're going to do B. And I like B because if you notice, B is a rational function. It is not continuous everywhere. Rational functions cannot have a denominator equal to 0. So F of X actually has a discontinuity. It is discontinuous at X equals 1 because X equals 1 is where our denominator equals 0. However, the interval that we are looking at is 5/2 or 2.5 to 4. We are looking at X values of 2.5 to 4. But 1 is not on that interval. 1 is not on the interval of 5/2 to 4. So we can still use IVT. As long as you are continuous on the interval that you are analyzing, then you can use IVT. Still need to consider any discontinuities in the function. And again, this function f of x does have a discontinuity, but because it is not on the interval we are analyzing, then I must be continuous by default on that interval. So I can use intermediate value theorem. So again, we are looking for a certain C value, and again, C is going to be an X value that produces a Y value of 6. In order for us to find that, we first need to make sure that we will hit a Y value of 6. So I am going to find F of 5 halves, and I'm going to find F of 4. I need to make sure that we will hit a Y value of 6 on this interval. And I can guarantee I hit a Y value of 6 if 6 is between the Y values produced by these two X values. Now, plugging in 5 halves especially, you might want a calculator. I've actually already done this, and I get 5.83 repeating. And plugging in 4, I get 6.6 repeating. And taking a look at this, the Y value that we have that goes with our unknown X value of C is between 6.6 repeating and 5.83 repeating. So that means there has to be some C value, in other words, C stands for X, so some X value that has to be between 5 halves and 4 that produced that Y value of 6. So how do we find it? Well, we are going to take 6 and we are going to plug it in for Y or f of x, and we are going to solve. Now, I know a lot of you hate fractions, so get rid of the fraction. I'm going to multiply both sides by x minus 1, distribute the 6 on the left, and I'm going to set everything equal to 0 because I can see that I have a quadratic. Subtracting the 6x gives me negative 5x. Adding the 6 gives me a plus 6. Oops, sorry, you can't see that. And factoring, we get, be careful with the signs here, x minus 3 and x minus 2. So we have solutions of x equals 3 and x equals 2. Now, again, take a look at the interval that we have. We went from 2.5, 5 halves, to 4. 3 is between 2.5 and 4. 2 is not. 2 is not the value we want. So C has to equal 3 because 3 is between 2.5 or 5 halves and 4. In a nutshell, again, intermediate value theorem simply tells us that if you have a function that is continuous everywhere, or at least continuous on a certain interval, then you can guarantee that the function must pass through every x value from the beginning and to the end of that continuous interval, and it also must pass through every y value from the beginning to the end of the y values associated with the interval. So I did link up, as I flip this over, I did link up some more practice for y'all to do if you would like to do that before you take the Canvas quiz that is also linked up here. So you may want to try these just to solidify your understanding before you complete this Canvas quiz. And you'll notice there's some questions in this Canvas quiz that are not math related, so please be honest. I'm honestly really looking for feedback. So yeah, just please be honest, and I will see you all next week. Let me know if you have any questions.